in another example here, let's say we have, here's my example number 5. Once again, let's try to solve for x. Okay? And the equation that we have here, x to the 3 halves minus 2x over to the 3/4 plus 1. And so, at first sight, when you look at this, it's really hard. I'm telling you, it's really hard to recognize the quadratic-like nature of it. Once again, let me point it out to you. And once again, if this is because if you don't recognize this because you are feeling weak with fraction, make sure you review your fraction skill. But here, let me tell you, 3 halves, isn't it twice a 3/4? Okay, 3 halves is twice a 3/4. So what I can see here is that I have a power x to the 3 half power, and here x to the 3/4 power is just exactly halfway down. And so once again, if you do not understand my explanation here, make sure you review your fraction skill in terms of the relationship between 3 halves and 3/4. And then the last term here has no power for x. So that means here I can see that the first term, I can rewrite the first term as x to the 3/4 power, whichever the halfway down power, and then I square that again. And then the next term over is 2 times x to the 3/4. Okay, and the last term is a plus 1 equals 0. So now I am seeing quadratic like. You got a square power, no square, and then the no power. So now in my next term, in my substitution points, I'm going to do t equals x to the 3/4 power. Okay, and x to the 3/4 power. I mean t equals x to the 3/4 power. So that means every single time anywhere I'm seeing an x to the 3/4 power, I'm going to turn that into a t. So my current equation is going to be turned into t squared minus 2t plus 1 equals 0. Okay, so once again, at this point, you can just simply solve for t. And let's switch direction momentarily. So we're solving for t. Keep that in mind. So solving for t here. Now with this current equation, what I can see is using the identity, the square of the difference identity, or you can just simply factor. That turns out to be t minus 1 and t minus 1 equals 0. And so I'm going to end up with precisely t equals 1 for the solutions of t. Okay, but now once again, keep in mind t equals 1 is not going to be my final point, because my final point here needs to be x equals something. Now, my goal of the problem is solving for x. So here solving finishing solving for t doesn't mean we finish with the problem. So I need to go back to the substitution point. Now t equals to x to the 3/4 power, and then t on the other hand equals to 1. So that means x to the 3/4 equals 1. And that gives me, for this equation here, once again, to solve that, we're just going to solve it using the technique that we learned in solving equation with rational exponents. So now x is going to be equals to 1 to the 4/3 power. Okay, and 1 to the 4/3 power is just the same as cube root of 1 raised to the 4th power, and all that really is equals to 1. Now, do I need to worry about the plus and minus in front of the answers? No, because if you look back at the rational exponents that I had earlier, the numerator was an odd number, so I do not need the plus and minus here. So this is my final answer, and there's only one final answer in this problem. Okay, so some more examples here to get you really comfortable with the quadratic-like equation. So what about in my example number 6 here? What do I see now? How about we solve for x once again? Solve for x. So my equation here is turning out to be 2x minus 3x to the 1/2 power plus 1 equals 0. So once again, we've had about 5 examples before this one. So hopefully you start getting a good grip on how to recognize the quadratic-like nature of these things. But now what I'm seeing here is for my x, my first term I have a power 1. My next term over is a power 1/2, so isn't it sure that the second term here has halfway power of, has a power halfway down compared to the next one, compared to the first one. So once again, I'm seeing that here I have whatever power that is. The next one here is halfway down, and the last one here is no power. So now that is something that rings me a bell about quadratic-like equation. So now I can rewrite the x here as x to the 1/2, and I square that power. That's what happened to my x variable. And then I put a 2 here. Okay, and minus 3 times x to the 1/2 power. And here I'm seeing my repeats of the x to the 1/2 power. And plus 1 equals 0. So now, what I have now is showing, the equation I have in front of me now is showing the quadratic-like behavior here. So I can just use my substitution point here to let t equals to x to the 1/2 power. Okay, and that is going to be my substitution point. And so t equals to x to the 1/2, meaning every single places where you see the x to the 1/2 power, anywhere you see the x to the 1/2 power, you're going to replace that by a t. So I have 2 with t squared minus 3t plus 1 equals 0. And so now obviously things turns back into a quadratic equation. And so now to solve this equation, let's say we're going to solve for t at this point, once again. Right? And I need to do factoring again. And I can see that here I need a 2t, and here I need a t equals 0. So that gives me a minus 1, minus 2 here. Okay, so that's how we factor our 2t squared minus 3t plus 1. Okay, so now that immediately produced for me 2t minus 1 equals 0, and t minus 1 equals 0. And so this first equation here, solving for t, I'm going to get t equals 1/2. Now, we've been having quite some good number of examples here, so allow me to skip the middle steps of how I solve for t in here from this first equation. So t, after solving for that, is equals 1/2. For this one over here, t equals 1. So I found 2 answers for t once again. So now, keep in mind, this is not the final answer, because the goal here is to solve for x. So we finished solving for t. That means something rings a bell that we're not quite finished yet. So what I'm seeing here is x to the 1/2 equals t. That was the substitution point. But t equals to 1/2. So that means on one hand, x to the 1/2 equals 1/2 again. So we can solve. So on one hand, what I was trying to say earlier is, on one hand t equals x to the 1/2. On the other hand, t equals 1/2. So that implies x to the 1/2 equals 1/2. And then I can also tell you, based on the substitution point, I can see that x to the 1/2 equals 1. So now with these equations here, I'm ready to solve for x. So to solve for x here, all I have to do is raise 1/2 to the 2/1 power. And I'm raising 1 to the 2/1 power. Okay? And that basically means 1/2 r squared. And over here it means 1 squared. And so my final answer would be a 1/4 for x. No need for the plus and minus sign. And here x equals 1. Once again, no need for the plus and minus sign. So my two answers here is x equals 1/4 and x equals 1.